Hi there, this is Jacob Nash, and in this video, we'll be looking at another integration technique, which is integrating using partial fractions. Um, I'm sorry if this video is a little off. I am a little bit tired right now, so I'm going to try my best to be as clear as I can in this video. So, what ways do we know how to integrate so far? 1 through 5, we've already looked at quite a lot by now, and if you don't remember any of these, watch the previous videos. But now we have a new way, integration by partial fractions, and luckily this is in my opinion, I feel like easier than number 4 and 5. Definitely number 5. How do you know if you need to use this? It's if what we're trying to integrate is a rational function. So if it's a function divided by a function, and I know you might think, hey, isn't that what we already have done in the last video with trig sub? But trig sub, remember, it always has a square root. These questions will not. And also, trig sub doesn't have to be a fraction. It could just be a square root by itself. Um, so what are the steps for solving a an integral like this? So first of all, here's a very good basic example of how it would look. Something like this. It's two functions divided by each other. And how do I know? We're going to have a video actually specifically on how do you know which technique to use, because that can get a little confusing. But I know that there's nothing I can do, like there's no antiderivative rules. I know U sub's not going to work, even if I factor this integration by parts, obviously not, because yeah, for obvious reasons, it doesn't look like that. And then no trig thing will work either. So this is what we have to do. The first thing is to factor the denominator if possible. I say if possible because we'll look at an example where can't, and you just do something a little different if that happens. But you can factor this, and it happens to be x minus 3 times x plus 1 if you factor that. Hopefully you remember how to do that. Um, Next, you Uh, forget about the numerator for a second, and you create two fractions with the factors that you just found. So x minus 3, x plus 1, and then you put an uppercase letter on top, and you start with A, and you go all the way to Z. Hopefully, you would never have that many, but in this case, it's only A and B. Those are the only two letters that we use. Next, you create an equation, the numerator on one side of the equation. On the other side, if you notice, that's this, but we kind of cross multiplied, it almost looks like. That's not what it was really, though. What it is if you remember, if you're trying to find a common denominator, you multiply by what is missing in the current denominator. So this a right here, it already has an x minus 3. It needs an x minus 1. So we multiply a by x plus 1. This b already has an x plus 1. It needs an x minus 3. So you multiply those together, and there you go. Now you have to find A and B. That's the next step. Find all the letters that you have. And you might say, hey, isn't there also X? No, that doesn't matter. It does the point is we're trying to make something that we can integrate, and we can obviously integrate if there's X. So we don't want to get rid of the X. We just want to not get rid, but like find A and B. Um, so the way that we do that is we have to do something that will cancel out either one, because you can't solve an equation that has two unknown variables unless you do that or something else. Like you could do system of equations, but that's pointless because all you have to do for this question is plug in something for x that will cancel out a and b. So if I want to find a, let's plug in 3 to make this b go away, because that would end up b times 0 here. And if you do that, a equals -3. If you plug in -1 right here, that will make that a go away. Um, or sorry, it will make that a go away, and then you'll find the b, which equals 1. I'm sorry. Once again, I'm a little tired. I don't want to mix up something. Also, there's a couple typos. This says plus right here for some stupid reason, but it's supposed to be a minus. And this says 1 when we plugged in -1, as I mentioned, that would cancel out the a. So if, those couple mistakes aside, We found out that A equals -3, B equals 1. Next thing you do is plug those into this and you integrate with that. So move down here. That's exactly what we did. We switched out the A and B for what we found. Now you can integrate. And usually when you integrate partial fractions problem, it ends up with ln's in the answer, natural logs. And technically you have to do a u sub, but here's a little cheat of how you can do it quick. You do um natural log is absolute value. That's always going to be there. It'll always be absolute value. And then in the absolute value, you put the denominator. So that's what we have here, right? And beside or multiplied by the ln will be the numerator divided by the coefficient. The numerator is -3. The coefficient is 1, so we have -3. The numerator is 1 divided by the coefficient is 1. We just have 1, and that's why there's nothing there. And so the answer equals, or the answer is this, plus C, because it's indefinite integral. Okay, this might look a little bit overwhelming. A problem like this you would never actually have to solve, but you may be asked to set up partial fractions for something like this. You might be thinking, what is all this? Why are there so many? Why is there Cx plus D? What is that? Well, first of all, you have to consider two things, and both of them are pretty much the same. Exponents that are in the denominator. I see exponents that are not 1, so that tells me I'm going to have to do something a little different. I see a 2. You think about the exponents that are on the outside and the inside. So the outside exponents mean that you're going to have to duplicate that denominator or triplicate. Duplicate and triplicate. Um, and then you see that too? That means that we start out with 1, an exponent of 1, 2. So you go 1, 2, exponent of 1, exponent of 2. And you have an A and a B. This one, only one of that factor. See, because there's no exponent means there's only one factor. So x plus 1. This has 3, so you make it 3, you have it 3 times, but the exponents increase each time. So 1, 2, 3. It stops at 3 because there's a 3 there. So 1, 2, 1, 1, 2, 3. Now, why is there on some of them something like that? Why are there 2 letters? That's because of the x squared that are in these factors. If I see a squared that's in the parentheses, that's the key thing. If it's in the parentheses, see, there's not for this one, but for these two, there is an x squared in the parentheses. That means that you're going to have to do a letter x plus a letter. And it's just whatever letter is next. So Cx plus D, Ex plus F, Gx plus H, Ix plus J. If this happened to be a cubed, you would instead need a quadratic on top of here, but we're not going to look at that. But squared is what you'll probably see, and if that's the case, that's what it's like. Down here, it's a little different. I mentioned earlier in the video, what if you can't factor something? So right here, I can factor this. It's x plus 2, x plus 3. But this second thing right here, I cannot factor. How do I know? If you tried to factor, you couldn't think of any, and if you do the quadratic formula, it won't work. And why won't it work? Because b squared minus 4ac will be negative. That's called a discriminant. It's what's under the square root in the quadratic formula. And if it's negative, obviously you can't do the negative of a square root. So that's why you know there are no factors, and that also means there's no x-intercepts, which if you drew that quadratic, it would just not touch the x-axis. So that doesn't really matter for this purpose, but you just need to know that if you think you can't factor, do b squared minus 4ac, and if it's negative, you're right, you can't factor. But you don't want to think you can't factor and then you actually can. That wouldn't be good. Then you would incorrectly do this. So always check that if you think you can't factor. And as it turns out, b is 1. So 1 squared minus 4 times 1 times 3. That would be 1 minus 12. That's -11. So no, you can't factor this. So you just leave it there. It's like, okay, you can't factor it. You want to be stupid like that? Leave it. And then since I see a squared here, all you it means is that you do cx plus d. So that's the only thing that changes, just like how it was up here. If you see a squared and the parentheses, you do cx plus d, or whatever letters happen to be next. All right, let's look at another example where we actually solve. All right, first step is to factor. It's pretty much already factored. You can't do anything for that. So now you just separate it. But here's the key thing about this problem. This is an x squared. Since that squared is right there, you have to separate it and increase the exponent until you get to what it was. So it's a 2, so we go 1, 2. You stop at 2. That's pretty simple, right? Then 2x plus 1, as you would expect. Next thing is to create this equation. It's the numerator on one side of the equation. The other side, what does this a make missing? It already has an x. It needs one more x, and it also needs a 2x plus 1. What does this b need? It already has an x squared, so it doesn't need another x. It only needs a 2x minus 1. This c already has a 2x minus 1, so it needs an x squared only. And don't get confused, it doesn't need an x cubed because you see both of those. You always go with what's highest. So that's just the concept of creating a common denominator, which hopefully you remember that. Um, but feel free to comment if you need clarification on that. But that's how it is. So it only needs an x squared there. Now, oh great, we have 3 letters to solve for. So how do we do that? Same thing as before, just choose something that will make the other things cancel out. If we plug in 0, that will make the A and C go away, so we're able to find the B. And it equals -1 when you do that. If we plug in 1/2, that makes the A and the B go away, and you can find the C. But there's nothing that will make the B and C go away to where you can find A, so we have to do something a little different. And um, you might be wondering, how did I come up with 0 and 1/2? You really just take the things in parentheses, you set it equal to 0. So 2x minus 1, that's how I got 1/2. And then uh, that's how I got 0 if you set that equal to 0. So that's how you do it. How do you find A? Well, all you have to do, we already know B and C, so that's pretty easy. All you have to do is plug in B and C and anything for X. Any number you want. You could choose -422, 539, but obviously that would be really stupid. So plug in something that's easy. So let's do 1. Plug in 1 for X, plug in -1 for B, plug in 4 for C, and then you find A and it's -2. If you plugged in any other value for X, it would not change your answer. Don't believe me, you can try it. It would not change the answer. So you can plug in anything for X, but do something that makes your life easier for algebra. So just 1 is easy. And then A equals -2. Same thing as before. We just take what we had right up here. And now we know A, B, and C. So we replace it right here. And then now we do our natural log sneaky thing that we know. So ln, absolute value of denominator, and then numerator divided by coefficient. It's just -2 divided by 1, -2. Hey, what's that? Careful, this one is not an ln because of that x squared. If you think about it, this is just a reverse power rule. So really this is x to the -1/2. You add 1, x to the -1, which is 1 over x. Then this part right here, um, for once we actually do have to divide by the coefficient. So far coefficient has always been 1, but this time there's a 2, so you do 4 divided by 2, 2. And once again, what's in the ln is the denominator. Okay, you will have some that are a little bit harder, where you actually have to do a system of equations. And even though this looks like it's a lot of work, it's really not. It's just a lot of writing, but it's not really that much harder. So let's start up here. Factor this out. You can't. because the b squared minus 4ac thing, you would find that out if you did that for this. So you can't factor. So you just do this way. And there are y's only because it's dy, and you can see that they're y's. It doesn't matter if it's x, y, z, anything. So the numerator right here is just going to be by plus c because of this y squared. Anytime you have a squared for something that you couldn't factor, you just put it up. You always make it two letters and then, like that, by plus c. Now you do the same thing as before. Numerator on one side of the equation. What does the a need? All this. What does the b need? All this. And we actually just multiplied those together already. Distributed that. So that by squared plus cy. Now we have three letters once again to solve for a, b, c. Luckily, if we plug in 0, we can find a because that will get rid of b and c. A equals 2. However, there is no number that we can plug in that will make us be able to find b and c separately because nothing will cancel out a and b or a and c at the same time. So now that's where you do system of equations. Technically, you can do system of equations for the other ones we've already done in this video, but what I showed you is less work. But so you probably wouldn't want to do system of equations unless you have to. Now, how do you do system of equations? Um, well, you could also do substitution as well, but that would be hard. If you remember back to like algebra 1 or something, like probably like when you're in middle school or high school, you can do substitution or elimination. But substitution would not be good to do here because remember, that means if we like solve for one of the letters, that would make it kind of crazy. So you don't want to do that. You want to always do elimination. And what we have to do is create two equations. How? Plug in any y that we choose any y that we want. Once again, you're going to want to choose a y that's easy. So we choose -1 and 1. You could choose any. Once again, you could choose any y that you want, but we're doing these because they're easy. So we plug in -1 into this whole purple thing here. And if you do that, you would get 1 equals 2 plus b minus c. Hey, where's that 2 come from? Remember, we found a. So that when you solve for c, you could do it either way. You could solve for c or b, but I just solve for c. C equals b plus 1. Now, what about this one? We plug in 1, we would get 9 equals 10 plus b plus c. That would get us c equals -b minus 1. Whatever you do, you have to make it something that's the same. Like if we solve for b or c, that's the only way the elimination will work, is if we do it like this. Now look over here at this blue. You just basically subtract the equations, or actually subtract or add. So in this case, add. And then that would get us 2c. These b's and 1's cancel out. So 2c equals 0, c equals 0. Now all you have to do is plug in 0 for c in either one of these red equations. I'll just do this one. 0 equals b plus 1, b equals -1. Now we know what a, b, and c are. So all we have to do is go back up to this green and replace a, b, and c with what we found. And we do that right here. Now we have 2 over y minus, why is it just y? Because b equals -1, so negative y plus 0. So that's why it's negative here. So now this shows you an example of partial fractions where sometimes after you do the partial fractions, you have to use another integration technique. It's possible you'll have to do partial fractions again or just u sub or something. But you can't do partial fractions again because once again, we can't factor this. So there's just nothing you can do. So the only thing that we can do is try to use a different integration technique. And this probably is the hardest part of this question. It's a little bit sneaky what we have to do. But we're looking down here at this, and what does this make me think of? This makes me think like I kind of wish this was just y squared plus 1. That's what I think when I see this. Because if it was, then I could use arctan. That's what I feel like when I see this. That's probably what should go through your mind if you see something like this. Now, how the heck can we make this denominator be something that we can replace with arctan? Well, we'll just have to complete the square. Completing the problem is that there's three terms. Completing the square makes there be only two. So that's what we'll do. Um, and well, actually, something that you we need to do first is the problem is that for us to be able to do arctan, there can't be a y on top. It can only be a 1. So we're going to have to do something to split the integral. So we do this, plus 1 minus 1. That's the equivalent, right? And that might seem so stupid, but just by us doing that allows us to do this that's in this purple. Now we have this, as you can see, we were able to split it because these are equivalent. So that's the purpose. And this right here, we have that, and then we have this over here. And then right here, I'll just start with this part right here. This is what we're talking about. This looks like arctangent, so all you have to do is a u sub, which actually is a w sub, and that's just because I'll talk about this in a second, but we already did u over there. But this is how we get this arctangent. Then this part, well, how are we able to somehow factor this now, or sorry, integrate this now? Well, u sub, because if you do the integral of or derivative of the denominator, that would help us cancel out the numerator. So that's exactly what we do. And then we would get, when we plug it back in, we get 1/2 1 over u. And we know how to do the integral of that and that. And that's how we got our answer. So this is a really hard problem, honestly, and um you really can only get better by things like this by practicing, but this wasn't even just partial fractions here at the end, that was just things we've already learned. All right, next thing is I didn't mention this yet, but sometimes partial fractions won't work at first. And how will it not work at first? If the numerator of the, or if the exponent of the numerator is higher than the exponent of the denominator. That's a good thing to remember. If that's the case, you cannot do partial fractions yet. You have to make it to where that's not the case. And what you have to do is long division of the numerator and denominator. That's not so fun, but it's not so hard. And I have another video going in more detail on it that's from 2021, and I'll try to post that in the description. But I'll briefly go over how we do this. So we put this thing over here, the denominator over here, inside of the dividend, you put the numerator. And what you do is first you multiply this x um, by, or sorry, you do this -1 times the uh, x to the fourth, and okay, I am sorry. I'm going to try this again. I was not explaining it right. What you have to do is figure out what we need to multiply x by to get to this. X cubed. And so then you just put, you slide this down, that's what you always do, and then subtract it by this minus what you just found. This is not an easy thing to explain. I apologize by that. I did make a video, as I mentioned a few years ago, where I when in more detail, but it's not, I don't know, it's the only thing you can say when you're describing it is this, that, this. That's why it's hard to explain, but I hope you see what I'm doing. This times this, and you put that there. Now you put it all in parentheses and you subtract. Now you're only left with that. You slide it down. This times this. So it just keeps lowering and keeps lowering and keeps lowering until you get to the bottom, and then this is your remainder, 1, because you can't do anything anymore. So you do 1 divided by this, but then everything else that we already found comes before that. So please review that, and hopefully you wouldn't. This isn't very common that you would see a problem like this, but I just brought it up just in case. But if you have to do that, remember this is only if the numerator exponent is higher. So this is what we get right here. Now we can integrate this. I can integrate every single one of these things, and it's done right there. So, oh, of course we have one more problem. This is kind of a long video. I'm sorry about that. I didn't realize there was even another problem. Um, okay, so if you first saw this problem, you might at first think you would, of course, you hopefully wouldn't think trig sub, because that's only if there's a square root. You might think, is there any trig identity I can use? I do see a secant and a tangent, but as it turns out, nothing would work for that. Because of the tangent squared plus tangent, that kind of throws us off. There's nothing we can really do for that. So instead, we just say, well, if those weren't trig functions, wouldn't it kind of look like a partial fraction? Like if those were x's instead, if it was x squared divided by x squared minus x or plus x. Yes. So instead, that's when we do a u substitution. Instead of switching them with x's, which is kind of counterproductive since there already are x's there, we'll just do u because u sub. So you replace it with u, you um do the u sub, and if you set u to equal tangent x, then that will actually cancel out the secant x. Um, so that's then we're just left with this. And this is just the same as before. These are like the two factors, a divided by u, plus b divided by u plus 1. Now you do the same thing as before. It kind of looks like you're cross multiplying, but you're really just multiplying by what it's missing. And then really easy to find A and B. You just plug in something that will cancel the other thing out. And then you plug back in the tangent x at the end because that's what we set u to equal. So that one's a you just have to do a u sub first. So that's just proving to you that sometimes you have to do more than one technique. All right, that's the end of this video. I'm sorry that I kind of sounded probably a little bit lost or confused during the video. That's just because I'm really tired and a little bit sick right now. So I'm sorry about that. But I hope that it helped to some extent. Thank you for watching.